August of 1901, two English academics, Charlotte Moberly and Eleanor Jourdain, took a stroll through the gardens of the Palace of Versailles, looking for the Petit Trianon. But as they walked, something felt off. The world around them seemed to shift. The atmosphere growing heavy and strange. They saw people in old-fashioned 18th century clothes, a woman sketching on the grass, footmen, and a man with a pock-marked face. It was only after a week of not speaking about it that they compared notes and began to believe they had stepped through a tear in time, briefly stepping into the world as it was over a century before. Their story, published in a book called An Adventure, became one of the most famous and debated tales of accidental time travel. This desire to break free from the straight line of time to see the past or jump into the future is one of our most powerful fantasies. It's a story we tell ourselves again and again. But what if it's more than just a story? What if the line between myth and real-world physics is thinner than we think? The idea that time isn't fixed is woven into our oldest stories. Take the ancient Hindu tale of King Rivata Kakudme. Searching for a worthy husband for his daughter, he travelled to the realm of the creator god Brahma for advice. Their meeting felt short, but when they returned to Earth, they were floored. Millions of years had passed, entire civilizations had come and gone. Brahma simply explained that time runs differently in different planes of existence. It's as if Earth's clock is a standard wall clock, while in Brahma's realm, the second hand barely moves at all. You see a similar idea in the Japanese legend of Urashima Taro, a fisherman who visits a magical underwater palace. He thinks he's there for 3 days, but when he gets back to his village, 300 years have gone by. These tales from opposite sides of the world are wrestling with the same idea. Time isn't the rigid constant we experience it as. As we entered the modern age, the stories got more technical. The early internet gave us the legend John Titor. Between 2000 and 2001, someone on a series of online forums claimed to be a soldier from the year 2036. He was on a mission, he said, to get an old IBM computer. He posted schematics for the time machine and made vague predictions about a coming American Civil War. Of course, his predictions never came true and were widely debunked. The whole thing was almost certainly an elaborate, well-researched hoax. But the legend of John Titor shows we have updated these ancient myths for a technological age. So we have ghost stories, divine realms, and internet hoaxes. It's easy to write these off. The Moberly Jourdain incident could have been a shared hallucination. But what if I told you that time travel isn't just fantasy? That according to the laws of our universe, it's not a question of if it's possible, but how. To get this, we have to leave the stories behind and dive into the mind-bending world of modern physics. Our journey into real time travel starts with one man, Albert Einstein. In 1905, his theory of special relativity shattered our understanding of time. Imagine you have a personal cosmic speed limit that you're always hitting. This speed is divided between your movement through space and your movement through time. If you're sitting perfectly still, all your speed is dedicated to travelling through time. But the moment you start walking or driving, you have to divert some of that speed from time over to space. The faster you race through space, the more you have to slow down your travel through time to compensate. And this isn't just a theory, it's been proven. Scientists have put super accurate atomic clocks on jets and flown them around the world. When they landed, those clocks were a few nanoseconds behind the ones on the ground. They had literally experienced less time. Astronauts in the Internet Space Station are living this right now. They orbit Earth at over 17,000 miles per hour, so they age just a tiny bit slower than the rest of us. So time travel to the future is scientifically possible, If you could build a spaceship that travelled at 99.9% the speed of light, a 5-year trip for you could mean that decades or even centuries have passed back on Earth. You would have jumped into the future, but while it's an engineering problem, it's a monumental one. The energy and technology required are far beyond anything we can currently achieve. Einstein's second great theory, general relativity, adds another twist. Gravity bends time. Imagine space-time is a vast flowing river. Gravity is like a heavy object dropped into it. A planet like Earth creates a small dip, causing the river of time to curve and slow down slightly as it flows past. But a black hole is like punching a massive deep whirlpool into the river. The water, time itself, swirls violently and slows to a crawl near the edge. If you think the real science of time is just as wild as the fiction, make sure you subscribe because we're about to go even deeper. Future travel seems to be on the table, at least in theory. But what about the ultimate prize, going back in time? This is where physics gets really complicated. One popular idea is the wormhole, or an Einstein-Rosen bridge. Imagine space-time is a sheet of paper. To get from A to B, you travel across the paper. But what if you could fold the paper and poke a hole through both points? That's a wormhole, a hypothetical tunnel through space-time that could connect two different points in space or even two different points in time. The catch? We've never found one. And even if they exist, keeping one stable would probably require some bizarre form of exotic matter with negative energy. Trying to hold a wormhole open without it would be like trying to keep a tunnel dug in dry sand from collapsing in on itself. And then you have the biggest headache of it all, paradoxes. You've heard of the grandfather paradox? If you could go back in time and stop your grandparents from meeting, your parent is never born, which means you're never born. So who went back in time to cause the problem? It's a logical knot that ties itself. You're trying to saw off the very branch you are sitting on. The late Stephen Hawking even proposed a chronology protection conjecture. Think of it as a kind of cosmic safety feature, suggesting the laws of physics have their own security system to prevent the timeline from being broken by paradoxes. As a simple, brilliant experiment, he once threw a party for time travellers, but only sent out the invitations after the party was over. His thinking was that anyone from the future could find the invite and show up. No one did. Some theories try to get around the paradoxes. The many worlds idea suggests that going to the past doesn't change your past, but instead creates a new branching timeline. Think of time not as a single book, but as a choose-your-own-adventure novel. By going back and making a different choice, you don't erase the original story. You simply flip to a new page and start a new branch, leaving the original timeline untouched and running parallel to your new one. Another, the Novikov self-consistency principle, says you could go back, but you'd be physically unable to do anything that would cause a paradox. It's like being an actor in a play where the script is already written. You can move around on stage, but you can't say or do anything that isn't already part of the plot that leads to your own existence. Recent research has even used quantum computers to simulate aspects of how information could travel through a wormhole-like system. It's important to be clear, these are highly abstract computers, models exploring the link between quantum entanglement and gravity, not a physical wormhole in a lab. So, where does that leave us? We've gone from the gardens of Versailles to the edge of black holes, from ancient legends to quantum computers. The myths, while not fact, show an intuitive grasp that time is far more mysterious than it feels. Science actually confirms this. Time travel to the future isn't science fiction. It's a direct result of the very fabric of our universe, where time can stretch and bend. Travelling to the past, however, is still stuck in a maze of mind-bending theories, cosmic-level challenges, and paradoxes that might be impossible to solve. Yet, scientists keep pushing. The quest to understand time travel has forced us to ask the biggest questions there are. In a way, our journey into the future has already begun, 1 nanosecond at a time. The question isn't whether time travel is possible, but to what degree, and what would we even do with that kind of power? Let me know what you think in the comments, and don't forget to like and subscribe for more journeys into the biggest questions in science.